Hello, let's continue our Sudoku adventure with Safer Shorter Distances by Emphyrio. So we have standard 6x6 Sudoku rules in every row, every column, and every 2x3 box. We are placing the digits 1 to 6 exactly once each. We also have killer cages in the grid. Those are the cells that are surrounded by dotted lines. Those are killer cages. Digits in a cage sum to the top left. So these three sum to 9. And additionally, we have a global constraint. I think it's called no 7. Two orthogonally adjacent cells cannot sum to 7. So if this was a 2, then this would not be allowed to be 5. In fact, none of these could be 5 because they would sum to 7, and that's not allowed by the rules. All right, and so those are all the rules. There's a link in the description if you'd like to try the puzzle yourself, and I'm going to get started right now. Seems like the obvious place to start is this given 3 here. We can't put a 4 in any of these cells because that would add to 7. So there's a 4 in one of these two. And so I guess the natural question to ask is, can the 9 cage have a 4 in it? The other two would have to add to 5. And actually with the 3 and 4 gone, we can't add to 5. If this was a 4, let me just write it out for you. If this was a 4, how are we adding to 5? We can't do 1, 4. We can't do 2, 3. So there's just no way. So the 4 cannot go there. The 4 goes here. That does exclude 3 from this cell. This 3 looks in, and this 3 can't be next to the 4. So it does put a 3 in the 9 cage. So the other two add to 6, which could be 1, 5 or 2, 4. Let's actually think more about this box, though, because I think we know the contents of the 9 cage now. There's a few ways to think about this, but maybe the outies might be the easiest way. So we know the entire box adds to 21. We also know that these add to 7 and this adds to 9, which is 16 in total. And so 21 minus 16 is 5. This cell has to be 5 or the sum won't be correct for the box. And so then this is 1, 2, 6. And then we need to make sure 1 and 6 don't end up next to each other or they'd add to 7. And so the 2 sort of needs to be in the middle of them. Like if this was a 1, right, we'd be forced to put a 6 in one of these next to the 1. Similarly with the 6, we'd be forced to put a 1. So this has to be the 2 in order to prevent that from happening. But we don't know the order otherwise. All right, so now maybe we think about this 9. It has a 3 in it. Okay, so in general, these cells are from 1, 6, 3, 5. We know this isn't 3 because of the 4. The 1 and 6 are not going to be next. Actually, the 3 is going to be in one of these. What do I want to say about that? And then I guess these are from 1, 2, 4, 6. Okay, 5 can't be next to 2. So 2's over here. So let's think about this a little bit harder. So one of these is a 3, and the others add to 6. Okay, so then there can't be a 6 in the cage, or that would already be too big. Okay, that limits it a little bit. Let's think about this. If this was a 2, then this would have to be 3, 4, wouldn't it? Yeah, if this was a 2, these would have to add to 7. Actually, this being 2 just in general is bad, because these two, by definition, would add to 7, because the cage adds to 9. And we're not allowed to do that. So this is not a 2. So that is a 2. 2 can't be next to 5. Okay, so 1 or 4. If this was a 1, then these would add to 8. So that would be 3, 5 only. And if this was a 4, then these would add to 5, and they can't. Yeah, because we know there's a 3 up here, so they can't add to 5. So, okay, so this is 1, 3, and 5. Very nice. Okay. There was probably a simpler way to resolve that, but that's what ended up happening for me. All right, so what are we doing here? It's tempting to pencil this row. Whenever you have a global constraint like this, you know, these cells are going to be limited by this row, and then also it's going to be limited by Sudoku, right, is what I mean, but then also limited by being next to something in this row. So let's just find out what that means. Okay, so I'm just going to fill 1 through 6 here, and then I'm going to get rid of the ones they can't be. So they can't be 1, 5, and then 1 can't be next to 6. Here they can't be 2, 3, and 2 can't be next to 5. 4, 6 is gone along with the 3. 4, 5 is gone along with the 2. 1, 3 is gone along with the 4. And then 2, 6 is gone along with the 1. Okay. Maybe that wasn't as fruitful as I hoped. Maybe it's this 9 cage then, because there's really nothing else to look at. Well, I guess we can play a similar game to what was played here, where this is not allowed to be a 2. Because if it was a 2, then these would add to 7. So this is also not allowed to be a 2, but it sees 1. So this is the more interesting one. So this can't be 1, 2, or 5. So it's 3, 4, or 6. Is 6 too big? Well, 6 would need a 1, 2 here. So 6 would be 1 here and 2 here, which seems okay. 3 would require 6. Can't be 1, 5, so it would have to be... Okay, so let's keep track of this. 3, these need to add to 6, can't do the 1, 5, so we're going to have to do 2, 4. So this would be 2, 4 with a 3. The 4 would require these to add to 5. Can't do 2, 3, so we'd have to do 1, 4. There would be 1 here with 4 here. But we couldn't do that either, because with the 3 here, this can't be 4. So 4 is actually not possible. Sorry, no, it would be a 4 here. Wait, what did I say this would be? Oh no, with a 4 here, we can't do 1, 4, because there's already a 4 there. And we can't do 2, 3. So 4 just doesn't work. And then 6, we said needed to be 1, 2. So this is always a 2. That's weird. This is always a 2 in both cases. This is 3, 4, or 6. We have to be careful about not putting the 3, 4 next to each other. So this needs to be the 6 to prevent that from happening. And that gives us the 5 sum here with a 4. And that resolves these dudes. I'm looking for... Well, let's just do this pair. This is 5, 6, so we know the order. We should know this digit. It's a 3. This pair is 1 and 5. So the 1 can't go next to the 6. So that's 5 and 1. Okay, so what are these 3? We need we need the 1, 2, 4 from here. So 1, 2, 4. Let's just fill all of this. 1, 2, 4 here as well. It's always 1, 2, 4 and 3, 5, 6. Huh. All right, so what resolves this? Probably like this 1, 6 here. So that's a 3, 5, 6. This is 6, 5, 3. And then 3 or 5 can't go next to 2. So that's 1, 2, 4, 2, 4, 1. And there we go. Solution's correct. Wow, it just sort of collapsed as soon as I got this 9 cage done. That was really interesting how this always ended up at 2 in all the cases. There may have been an easier way to approach these, and I just wasn't thinking about it right. So, but that happens. Case checking is a little annoying sometimes to do, but it will get you results oftentimes. All right, well, I hope you enjoyed this. And of course, if you did, then why not leave a like, subscribe, and a kind comment below.